Hello, and greetings from the TMI Dynamatics team. Welcome to our webinar on Virtualized Logistics Supply Chain Simulation. Before we begin with our webinar, I would like to thank you for joining us on behalf of the TMI team, which is not only the people you will meet today, but also the people working off camera. Our goal with this webinar and the ones to follow is not to demonstrate our logistics supply simulator, but to engage into a discussion with you on how simulation can optimize your logistics supply chain and or training platform. My name is Mariana Barrones, and my role at TMI is to bring you and the team in TMI together to build lasting business relationships. At TMI, we believe in the power of digital innovation, but also we believe in the power of people to make innovation work. One of our values is our commitment to support you to innovate through the reinvention of the latest technologies and enhancement of training platforms. Please remember our webinar is recorded. This means that there is no need to take notes because we will share the recording after the webinar. The schedule of the webinar is as follows. First, I will present our keynote speakers. Then Mr. Moodley will give you an introduction and background. Then Mr. Rose and Mr. Stanley will go through a simulation demo with a case study of Durban Maritime Harbour. Then Mr. Moodley will go through a conclusion, and then we'll finish up with a Q&A session. If you have any questions during the webinar or would like to carry on with a detailed conversation, please remember to send us your questions through the chat. We will make note of their inquiries. Due to some time restrictions, we will select the most relevant questions to answer in our Q&A. Please know that all your inquiries are valuable to us and that we will answer them as soon as possible through emails. And now, on with the show. Let me present our keynote speakers. Okay. So, Mr. Tibash Moodley is the current Business Development Director at TMI Dynamatics. Tibash trained as an aeronautical engineer and project manager. Tibash has acquired 22 years of experience in management and leadership in aerospace, maritime, logistics, and education industries. He has been fortunate enough to work with industry experts in BAE systems, SAB systems, Denel, Transnet, ESCOM, and others to design, develop, and deploy world-class simulation for engineering, analysis, and training. Coupled to this, he has undertaken academic projects with CSIR, MIT, TU Delft, KTH, BITS, to develop simulation technologies to demonstrators, with applications in several industries. Mr. Wouter Roos is the current Operations Director at TMI Dynamatics. He has trained as a solution-driven engineer. Wouter has acquired over 15 years of experience in designing, developing, and manufacturing real-time simulators and online training solutions in logistics, aerospace, maritime, education, industries. He has also been fortunate to work with industry experts in several industries. His current goal and aspiration is to design, develop, and manufacture affordable, state-of-the-art simulators that integrate training solutions to be used across the globe. Last but not least, Mr. Brian Stanley. He is a facilitator and project manager and one of TMI's go-to coaches and mentors for maritime industry solution implementations. Brian has acquired over 27 years of experience in project management, rail planning, ships planning, yard planning, equipment controlling, mentoring and coaching, as well as being a key player for the implementation of the current terminal operating system, NEWIS. His current goal and aspiration is to impart the knowledge and skills gained through studies experience to upskill individuals to be able to implement optimal working solutions with efficiency. So let's go forward with our presentation.
Okay, thank you, Ms. Baron Esquivel. And yeah, it was awesome to be part of this webinar. And actually, I think it was quite innovative for us to bring it together, because we were always trying to show how could we bring a massive simulation solution to the industry. And thanks to COVID, we learned from other webinars and we decided to develop our own webinar. But I think what's important here is to basically give you guys some background into where we come from, to help you understand why we see a very important role of simulation, and more so simulation 4, in the Port 4 ecosystem, as well as the new terms that are being thrown around in Port 5, well, the Port 5 concept. Yeah. The company was founded in 2005, and it has a 14-year track record in engineering simulations, as well as immersive training simulators. We founded the company on the backdrop of the aerospace and defense sector in South Africa, and we were fortunate to provide solutions to your global entities that Mariana has mentioned. And from that, we've managed to acquire world-class skills, experience, and technologies in simulation and training. And on that note, we started looking at opportunities on how we could localize and customize this world-class technology for the South African market. And coincidentally, in 2009, when our previous Minister of Transport announced that his vision was to see all grade 12 students matriculate with a driver's license in the one hand and a matric exemption in the other hand, we saw a great opportunity to use this aerospace technologies in the aviation sector to develop driving simulators for the South African market, to enable our youth who are not, where most of them are not actually and can have the affordability, or actually cannot afford the luxuries of owning a car within their family. And how do you teach somebody like this with very little exposure to driving, and actually where most of their lives they spend in the back of buses and taxis? And so using simulators and driving simulators, we managed to give them exposure, as well as we managed to give them some sort of immersion into what it feels like to drive a motor vehicle. And it was quite astounding how the learners actually took to the art of driving in a driving simulator. And when we put them into the real vehicles, they actually took to it. And given on this backdrop, we saw there's other opportunities for our capabilities in modeling and simulation. And that's where we went to our local maritime companies and said, we have this technology from the aerospace sector. We've championed it in the driver training and logistics sector. And now we see that the same technology can be used in to develop maritime simulation and training solutions. And because of that, we've developed what we will be demonstrating today, the logistic chain simulator, which basically simulates an entire logistics chain from start all the way from the buyer all the way to the seller. And the beauty of that is it shows you step by step procedurally the documentation, the processes involved, and all the equipment that's involved in handling this cargo from the warehouse or from the factory to the end user. And on that background and on that technology that we developed in the maritime with regard to the logistic chain simulator, we also developed material handling simulators. But how does this all fit into the ports environment? And why are we here telling you about a virtualized logistics supply chain? And it all boils down to the evolution of the ports over time. In the 60s, your ports, which was the Port 1 concept, or the Port 1 as it was known, it was very labor intensive and very paper-based, right? There was a port manager that managed and controlled the entire port terminals, the marine, the commercial sector, and everybody worked in silos. And it was all about moving paper from one person to the other, as well as physically handling cargo. by manual processes or semi-automated equipment and machinery. And then we got to the Port 2 concept, which was between the 60s and 80s, where we started developing processes that enabled different elements in this logistics supply chain to start communicating with one another seamlessly. And these processes enabled people in the terminal to communicate with people in the marine sector, as well as in the commercial sector. And what we found was there's some time efficiencies, and we could move cargo faster through your ports environment. But we still had background and challenges in that. And then we had the Port 3 environment between the 80s and the 2010, whereby we started integrating and automating equipment, but still there was this process-orientated, but also very manual operations in the ports where communication and information was not easily flowing. Since 2010, with the introduction of high-speed bandwidth and stuff like that there, we had the ability to integrate solutions and systems, and we got to what we call the smart port ecosystem, where now your port and your city integrated when it came to dealing with your rail, intermodal transport, rail and road, that now could seamlessly interface and interact with your terminals and your water side of the business, right? And this way we could predict traffic flows much easier, as well as control and monitor traffic flow. And that was very important in the evolution of ports. But where does simulation fit into all this? And I think that's very important for us to understand. What is the role of simulation? And I'd like to just touch on how simulation also evolved. And I'm not going to go into the details of it, but the first type of simulation was about simulating hardware components, seeing how they worked, and then understanding what the implications are of these components in an operational environment. And then in simulation 2, we started developing tools that enabled us to simulate faster and model faster. But simulation 3 brought about basically simulation-based, where we had multi-bodies interacting with each other, and we were simulating multi-level and multidisciplinary systems. And now we're at a stage where, due to the luxuries of high-speed internet connectivity, a lot of automation and digitization on your equipment level, we now have what we call the digital twinning. And the value of digital twinning is where we can seamlessly integrate hardware and equipment in a software world and run a software, part hardware, part software, to actually replicate and run real-time parallel systems with hardware and software. And the beauty of that is basically, you're really solving a lot of your challenges in the real world in a virtual world. So the benefits of Industry 4, the high-speed internet connectivity, real-time sensing systems, big data analytics, literally paved the way for Simulation 4 and your digital twinning. And over time, this has saved large amounts of money for the industry. And this is why we believe Simulation 4 is the technology that can digitally transform your port. And the reason why this is happening is because the maritime market dynamics is demanding quite a lot from the industry, from the logistics industry. Buyers and sellers are continuously looking for speed to market, safe handling of their cargo, affordability, and moving smaller volumes faster. And what has happened in the early 2000s, we found that the air freight industry placed a lot of pressure on our maritime industry because it could move product faster. But over time, the maritime sector has gained some of this ground back. But what's the challenges with achieving Port 4? We have lots of legacy systems in the port that still works very well. They're not digitized, they're not automated. How do we integrate all these things, right? As well as a lot of the aged hardware is still analog. And we have this huge problem in the digital world of cybersecurity. But now what we need to look at is how do we manage this from a demand side? Port authorities are continuously looking to try and improve and adapt new models from a smart port concept. And what we're trying to say to you guys is, prior to investing in infrastructure, equipment, processes, and people, simulating in a synthetic virtual world to confirm performance, reliability, and revenue is paramount. You're going to be saving lots of money and time and people's effort to ensure that the way you set up your new port or your port 4 or port 5 is going to work for you. And basically, what's going to happen is, with this level of digitization and automation that you bring into your port, you're going to achieve port 5. And to showcase this, we have to tell you what we're seeing as the port 5 concept. And this is no longer about an individual port. It's integrating ports across the globe. So port-to-port integration with the benefit of high-speed connectivity, as well as a lot of cloud applications. Your real-time location systems, GPS, LiDAR, OCR, and RFID, as well as autonomous and remotely controlled vehicles that can control your hardware, robots and drones to monitor offshore and inshore activities, big data analytics and business analytics to enable us to use artificial intelligence to predict operational challenges and opportunities. With simulation, you have this wonderful trade-off. Do we focus on large capital infrastructure spend, or do we use simulation-centric phased investments to achieve our goals? And that is why I'm here with my colleagues today to demonstrate to you a case study that we undertook in the Durban Maritime Harbour, where we literally simulated the entire port. And we basically simulated the water side of the business, the terminals, the terminal equipment, the intermodal transport, rail and road, and we achieved something quite phenomenal by assisting a local port authority optimize and improve their port operations. Thank you very much. I'll hand over to my two colleagues, Brian and Wouter now. So.
Thank you very much, Deves, for that brilliant introduction. So myself and Brian will go through the simulator, but before we start with the simulator, I just want to give a bit of background information of what we'll be showing and what we've done, and also why we've done it. So as Deves mentioned, we're doing a simulation for the case study of the port of Durban. So we've modeled Durban Harbour, and the waterways, the terminals, everything is there. But today we'll only be focusing on the container terminal, just to the time constraints we have. But all terminals can be simulated, multi-purpose terminals, liquid bulk, passengers, anything can be simulated, and it can also be customized to your specific port. So please keep in mind we're just having a very specific scenario today, the port of Durban. So what does a simulator do? What does our logistics supply chain simulator do? As Deves mentioned, it simulates the whole process from bringing in cargo into a country or exporting it. So that starts with the buyer having the need for a product. That product goes on to, in this case, obviously the port, it's a vessel, but it could be others, aircraft, other intermodal modes of transport are also possible. Everything that's required from bringing in the vessel into a port, offloading cargo, storing cargo, and how the cargo leaves the port. So that whole process is simulated in our simulator. So we've set it up, typically it's a training simulator for people in the commercial, in the maritime, in the terminal environment, and they all work together in what we call a virtual scenario or a virtual port. So I'll be going through that now. So if we look at the 3D of the environment, the UI, which will be shared shortly, we see an overview of the port of Durban. And this focus today, as I said, is on the container terminal. So in the center of the screen, we can see the cranes, and behind it, we can see the stacks for where the containers will be placed or where the containers will be picked up from. We can see there's some vessels on anchorage outside the port. There's some tugboats as well, and there's some roads. So this is a very schematic overview of the current situation in the port. So as the simulator starts running, the student can see what is happening in a glance. Then it also supports a 3D view of the port. So not only do we show the 2D, but also the student can have a look around what is actually happening. So we got all the containers. So I'm looking now at the yard stacks. We'll go into more detail that later, but all the containers that are in the simulator are here. And the student can even zoom in and have a look at all the numberings on the containers. So later in the planning that will come back. Then we also have the rail, we got the vessels that anchor it, so I'll show them quickly and we'll come back to that later as well. So these are all the vessels waiting. So the student typically has his own station. It can either be in a classroom, but also nowadays we offer a cloud-based solution where they can log in from anywhere in the world basically and have access to these same programs. So the student logs in and has access to this program, for instance, which is we call the UI. It has an overview, marine services, we go through all that compliance. There's also on the commercial side, we have a program where all the commercial activities take place. So each student can start and close these programs as they please. And communication between the role players is typically done by email or telephone. So depending on if it's a cloud-based system, that's very useful to have email and telephone systems. If classroom-based, obviously, there's also interperson communication possible. So that's basically the introduction to the simulator. So it serves as also, as Tevez mentioned, it's a digital twin of a port. It can be customized in as much detail as necessary. And then I would like to hand over to my colleague Brian to start with the commercial introduction.
Okay, so looking at the simulation process is actually very exciting to present what we have to offer at the moment. There are many experts in the field that have put a lot of time and effort into doing this, and you will see the results from the actual simulation when we are running through it, and you can see how adaptive it is and how clear you can make your current processes visible to maybe where you're looking at bottlenecks and where you're looking at delays that can be enhanced to a certain stage that you can streamline processes. So I think that's the good idea behind what we're showing today. And also beyond that, it allows you to put in different scenarios that you might be considering within a port environment, maybe for optimizing your processes, and see whether it works for you with the equipment that you have, maybe your terminal layout and so forth, and it makes it a little bit easier for you to understand what to expect going forward. So the simulation, as well as we just saw now, is very detailed. There's a lot of specifics in it. If you please take note as we run through it, the detail involved is actually amazing, from light poles to wheels to markings on the ground in terminals. All can be customized according to what your port requires. And the important thing about the simulation, it covers three major aspects as it stands. So we're speaking about the commercial side of things. Also, we're going to be focusing on the marine side and the ports itself, which is terminals that we'll be going through as well. So the overview that we're going to be providing, believe you me, it's much more detailed. We're just trying to skim through to give you a good understanding of it and how you can relate to it and what to expect from the actual simulator itself. You'll find a lot of the roles are interlinked. Sometimes even if it's not interlinked, you find they overlap each other. Others might run parallel to each other, and it's specific. The roles are specific in certain cases, and some of them are time sensitive, and you'll see exactly what I mean as we're running through the simulation. The complete chain that we're speaking about, the logistics supply chain, is what we're trying to get the end user to understand from interacting with the simulation process. So I think that's key, and keep that in the back of your mind as well. So running through commercial, we see that there are several documents that need to be lodged ahead of time, sometimes by different role players as well. When it comes to the commercial side, a lot of documentation is involved, and with this documentation, you also find the various individuals that need to pass these documents. Some of them are the vessel agents themselves, the clearing forwarding agents, customs officials, and transporters, and there are a few others as we go through the terminals and marine side of it. It'll bring a little bit more clarity there. At the end of the day, these are time sensitive. And in the maritime industry, time is money, and it can translate to major delays if certain documentation are not put in place. So we at all costs are trying to avoid these bottlenecks, these delays that sometimes are quite evident in ports, but it's just an understanding of how to get rid of it would make it a little bit more easier. So as I said, the different role players we're looking at are your buyers, your sellers, your vessel agents, clearing and forwarding agents, also your finance, recouping of the tasks that have been done, how you recoup your finances, and then the customs and excise and so on going into that. We find that the instructor's role within the actual simulator will be that of the documentation center in any common port that you might find. And there's a lot of information involved within the documentation center as well when it comes to certain EDI files, your electronic data interface files and so forth. We will be running through that as we get closer to some of the sections as well. You find the seller and the buyer, which is the consigner and the consignee, provide the following documentation, which is your commercial invoice for the total cost of goods. This is quite important and it will come to light in a little while. Your packing lists detailing the contents of your cargo. Also, we're looking at your manufacturer's certificates, your permits for your IMDG, your dangerous goods stuff, and also your packing declarations, police permits, and so forth. We also, Voter will currently be running through some of the documentation that you will see on the commercial side via the simulation process and what needs to be done and how it needs to get done. Thank you, Voter.
Thank you, Brian. So if we look at the simulator, I've opened up the commercial interface where the different role players can generate the documentation that Brian just spoke about. So typically how that looks, for instance, a packing list, the seller or buyer can create a packing list. And it's a standard format that we're using here. If you want a specific format, we can implement that. But it's basically just to teach the role player where to get the data from, what data is required in this specific case for the packing list, what goes on it, what needs to be calculated, and all those kinds of things. So we provide the information in the scenario. The role players just need to gather that information from the right place, understand which one is applicable, and then apply it to the packing list, in this case, for this form. They save it and they send it off to the correct role players that need to receive this data. Similar to that, we have a commercial tax invoice. It looks very similar, it just has this extra cost and the tax included, and so that needs to be calculated as well by this role player. I'm going through it quite quickly. These are just documentations. We can customize this to specific needs. Then there's the dangerous goods declaration. In case there is something like explosives to be imported, there needs to be a declaration. The ports need to know beforehand what kind of material is it, where does it need to be stored, does it need to be taken off during daylight, for instance. There's restrictions on some materials. So it's important for the port to know what is coming. So typically all these processes have to be done long before the ship actually arrives, or even before it's loaded, even on the others, on the port of port of origin. Similar to that, there's also the terminal goods, dangerous goods container terminal order. In this case, if it's a container transported good as well. So all these documents need to be completed by the buyer or the seller and need to be submitted to the terminal. Okay, then we can move on to the clearance and forwarding agents. Their roles, I'll quickly explain that as well in the simulator. So they need to create a bill of lading for the container, or in this case, or the whole vessel can be as well. So it's type of, the container needs to be identified, what is in it, the weight, all these typical dimensions need to be filled in and created, and once again sent off to the terminal before the vessel arrives. And then finally, there is the SAD 500, which is the South African customs form, which we've incorporated. So everything needs to be filled in correctly. The duty needs to be calculated. So we give the role player the tariff book. They need to determine what type of goods or material am I importing, what is the tariff for that specific good or material, and they need to calculate the duties, the taxes and everything, and submit that as well. And this goes to customs. Another role for the vessel agent is to create all the pre-bookings and pre-advices on the system, which is for the container terminal. We'll go in. I'm not going to show how that's done because it's quite detailed, but we'll touch on that later, where that information is used in the terminal. Okay, and I think we can move over to the vessel agent.
Sure. So looking at vessel agents, what we also need to understand, a lot of documentation today with the digitizing of ports and automation of ports and so forth. And as Tibesh was speaking about the actual internet, the speeds that we're having now, a lot of documentation also flows through EDI, which is your electronic data interface. And the vessel agents, some of them, you'll see the roles that they play and what happens with regard to this. The vessel agent itself is in charge of the inbound and outbound cargo for that vessel. And the vessel agent is responsible to determine the route of that vessel as well. When you speak about port rotation, you'll understand a little bit more clearly as to the role there. And in doing so, there's a lot of documentation that comes ahead of time that needs to be inputted into the system, not only sometimes manually, not only into the system, sometimes they need to hand deliver certain documentation, and you'll see a little bit why. We're speaking about the vessel arrival notification, for example. The vessel arrival notification, if not submitted, we will not know or understand when this vessel is coming in, what's the purpose of it coming in, which terminal it might be going to, and so forth. Also, the marine services that might be required, for example, a pilot on board, getting the vessel into the terminal, leaving the terminal. Also, the bill of lading, which can be prepared for the vessel by the vessel agent. Also, the forwarding agent as well. It also speaks about the departure and arrival times as well, which is important because the vessel agent is in constant communication with the chief mate or the captain of the vessel. And if there are delays, if there are issues, it's relayed directly. And you'll see a little bit now when I'm speaking about the different role players as we go into marine side and when we do go into terminals as well with regard to this. As well, we find pre-advices that can be done on the system. It needs to be done ahead of time to ensure that we can start receiving cargo ahead of time as well, to make sure that there is no delays with regard to this. And when we get to terminals, we'll see that. Also, we'll be running through a little bit more with regard to the vessel notification.
Yeah, so in the simulator, it looks, it's quite a lot of detail. Obviously, the port needs to know exactly what is the vessel that's coming in, how big is it, when is it leaving again, what does it need? Does it need cranes? Is it offloading passengers? All that information is captured in this form, and it's actually the start of a scenario, because as Brian mentioned, if the port doesn't know a vessel comes, they won't service it. So it's very important that this is filled in correctly, because everybody in the port, the marine services, the terminal, will use this data. So it's a lot of the information. Once again, the role player gets it from the scenario data pack. They get all the information, details of the vessel, and then they email it to the port or the role player that has the port. Okay, then we can move over to finance.
We'll see within the finance view, we're looking at the role player will prepare the bill for the revenue that must be paid to the actual terminals who provide the services, and for the port services rendered and so forth. In the view you're looking at now, Voto will just give a little bit more detailed explanation as to what's required there.
Yeah, so we can see there's a marine and a terminal side to revenue. On the marine side, there's costs like vessel traffic services, pilotage. So each of these individual actions have a certain cost to it, and that is normally calculated what's called the pre-bill, what we're seeing here. That is done before the vessel arrives. And it gives the vessel agent, but also all the other role players, a good understanding of what actually is costing money at the port. For instance, if there's a delay, somebody at the terminal might not fully understand that there's extra cost involved, or maybe there's an extra restow, the crane needs to do extra work. So all these kind of costs need to be calculated by the role player, but the other role players as well get a good understanding of what actually is happening in the port and where does the money come from, how does the port generate revenue.
I think looking at the customs and the clearance duties that's payable, once all of the containers have been pre-advised and cleared, and the clearing and forwarding agents has cleared all of the containers as well, customs needs to complete the table. We'll see that a little bit more detail there on the simulation as well. And the commercial module, it basically releases the containers. Or else, if not done, that container will basically stay in port until this is done. For whatever purpose, sometimes customs might even detain a container for like a police stop, a customs stop, or something called a TMI, a tailboard inspection. All of these things custom links directly to and engage in either detaining a container. Sometimes a container can be what's called stripped and repacked, or unpacked and repacked to maybe suspicious. Maybe they get a tip off that there's something suspicious in this cargo, and this can happen as well. So that's all the role of the customs and clearance there.
Yeah, so the role player that has the customs if the box is not released, then it can't leave. So it's a very important role, and it's just to verify that everything has been submitted. Was there a bill of lading? Was there a commercial invoice? Was there an SAD 500? So that's the role of the customs in this. It's more of a checking role and then releasing the final goods to be released, and they can be imported.
Okay, I think we want to move over to the marine services overview. And with regard to marine services, this is where you find the ports are active. You will find the harbor masters and so forth. And we're going to go into a little bit more detail there. The simulation as well provides an extremely detailed view of what's either expected or what's done and how it's to be done to achieve these marine services. So you will find it encompasses all water-based services that are provided by the port. And by saying that, I mean your vessel traffic control is involved, where they're monitoring your traffic of the actual vessel itself to and from. Outer anchorage, when your vessel is at outer anchorage, it's monitored, prioritized accordingly. And remember, I said overlapping roles. These vessels are, in fact, spoken about earlier. Documentation is submitted earlier, sometimes up to 21 days, even earlier than that sometimes, to ensure that when it does get to outer anchorage, it's prioritized accordingly and brought in accordingly. Providing of pilots, tugboats to the vessel to be brought into port. Also the actual berth allocation, planning of slots into the actual harbor environment. You will find that the berth planning is also done. Now remember, don't confuse it with terminal berth planning. I will be speaking in much more detail a little bit later with regard to terminal berth planning, and these roles run parallel to each other and sometimes overlap as well. Also, we find that providing of basic utilities such as your electricity, water, things that we take for granted when a vessel comes in, they need to be connected to these services, and that's what's provided there. You find also that the marine services in the port, again, as I said, water services that it's known as, or the water side in the ports, as we call it. The simulation covers the exports, the imports, and even the transshipment scenarios. Transshipments are your containers that come into the port via a vessel and doesn't leave via rail or road. It goes back onto another vessel to a different destination. And the marine services employs a system called the IPMS, or the Integrated Port Management System. And this speaks directly to the arrival notification of that vessel. And again, I say this is done prior and ahead of time. The creating of the actual vessel visit so that we understand the details, where is it going and so forth. Assigning a berth or time slot for that vessel to be brought in and taken to its specific berth. Also creation of different service requests on arrival, whether you're shifting a vessel, you're sailing a vessel, warping off a vessel and so forth. And then the assigning of time slots for those service requests, and the overview that you will see with regard to the actual marine services is detailed, specific. I said sometimes time sensitive, and it's important to keep this in mind as well. They also, in doing this, they also liaise with different individuals, the vessel agents, sometimes the terminals, and I'll be introducing a few more roles that are linked to them as well. Now, Vote is going to be taking us through a little bit of the simulation process and what happens and how it happens with regard to this.
Yeah, so if we start looking at the marine services, as we mentioned at commercial, everything starts with a vessel visit. So these vessel visits are received by marine services as well, and they're loaded on the integrated ports management system. So once they're loaded, everybody connected to the system, which is your marine, which is your terminal, basically everybody working in the port, has access to this information, and it tells them there is a vessel coming and when it's leaving, but also what needs to be done with that vessel. So if we have a look at the vessel visits that are currently loaded, I've loaded 16 vessels, but for today we'll only be focusing on one vessel, the Serangoon. which is coming to Durban, which is correct, we're in Durban, and it is the ETA is in 2 hours time. So now Marine Services can start planning. It knows that the vessel is coming in, so the next step is for berth planning to determine where on the berth this vessel can go and what terminal it needs to go to. So if we switch to the berth planner view, we can see on the right again, all the vessel visits are there to see, and they need to be planned on the berth. If we look at the left here, we have a view at the top. It says container terminal. That's the terminal we're looking at the moment. We have berth 203 at the top, and we have berth 204 at the top. So these are the two berths that we have at the container terminal at Pier 2 in Durban. And if we look down, we can see here, this is our vessel, the Serangoon, and it's the width here, we can see the numbers, those are the bollards. So that's the spacing along the quay of the vessel. So we can see this vessel is roughly 20 bollards long, so we need to space it with 20 bollards. And if we look at the vertical axis, we can see the day and the time as well. So the longer it goes, further down it goes, the longer the vessel will stay in time. So it's important to know as well when a vessel is leaving, so another vessel can be planned. So we can see here the vessel on the left is leaving at 2 o'clock at night, and then at 6 or 5 in the morning, the next one is coming in. Just as a note, typically vessels stay for multiple days. I've just for this scenario reduced the time that they'll stay so we can see more vessels for the simulation. So if we're at the top, we can see different terminals as well. They need to be planned. So if a vessel has liquid bulk, it obviously will need to go to the liquid bulk terminal. So it's very similar there as well. You need to plan it. You need to space the vessels in time and in space. Multi-purpose, the same story. Passenger, it's all the same. But now, say for instance, we have the Chicago on the left here, but now there's maybe the crane breaks down and it can't leave at 2 o'clock. So that's fine. But the problem is the Rosa comes in. So the berth planner continuously needs to update the planning with delays. Maybe a vessel is delayed coming into the port or something else is happening. So there's continuous updating for the berth planner happening during the simulation, but also in real life it will be the same. So that is the role of the berth planner. Then we can move over to vessel traffic services. You want to start with that, Brian?
Okay. So vessel traffic services, we find the detail involved with them is, we spoke previously and I touched on this already. And vessel traffic services, the role they're playing is the monitoring and also executing on the service requests you find as well. And with regard to the vessel traffic services themselves, it's a system that's employed and they use radar and so forth to monitor vessels. And in doing so, they can track every movement of the vessel. And also the simulation gives us a very good view here. And also the vessel traffic services speaks about the slotting as well on the vessels.
So if we look at the simulator at the vessel traffic services and the service request in particular, we can see there's slots in time, and it's also once again the planning of the Marine Services. It's a job to plan them accordingly. So maybe it depends on the ports. Typically there could be, they can service 2 vessels per 2 hours. Maybe another port can service more vessels per hour. So that also needs to be taken into account. So if we have a look here, we can see that I've already planned the arrival of the Serangoon. So there's different activities as well. There's the arrival of vessels, the sailing of vessels, there's a vessel leaving the port, there's shifting, which means moving along the quayside, there's warping as well, which means turning a vessel around. So all these activities need to be planned and they need to be requested as well by the vessel agent. So I'm going to bring in the Serangoon as planned here, and the first step will be to send the vessel to the pilot point. So we need to make sure before we send the pilot to the vessel that the vessel is ready, and so we don't waste time with our pilot. So I'm going to send it to the pilot point, so that would be in real life communicating with the captain of the vessel. I've started it. I'm also going to start the simulator at the same time. So we can see the vessel starts turning and moving towards the port. And a nice thing with the simulator as well, it allows the instructor or the facilitator to actually either pause the simulation when there might be something like a crisis and it needs to be explained. You get that opportunity to pause everything and instruct people, but you can also speed things up, so you don't have to wait in real time till a vessel comes in, or wait days for a whole scenario to play out. So I'm going to speed it up to 30 times real speed. I'm going to zoom in. We can see the skyline of Durban, we can see the port in the distance, and we can now see the vessel has stopped. So it is now at the pilot point, and the next step will be to send the pilot. So in the case of Durban port, we send the pilot via helicopter. And at the same time, I'm going to send the tugboats as well, because they're going to take longer to arrive at the vessel. So the 2D here to overview, we can see the helicopter going, and we can see the vessel going. And in the 3D, if I zoom in a little bit, we can see the helicopter coming, dropping off the pilot onto the vessel. And then the pilot takes the vessel through the channel into the port, where it will meet up with the tugboats. So we've modeled for the Port of Durban the typical waterways that they use. They have an entry channel, and all the terminals are in the right position. We take the timings into account. How long does it take for a vessel to go to a certain berth or a certain terminal? So all those things are accurately modeled. And we can see here the tugboats are already waiting. And the next step will be, go back to Marine Services, to line up the vessel to the tugboats. There we go. So we can see the tugboats now alongside the vessel. Takes a little bit of time to line up, and then the tugboats will guide the vessel into the port, to the terminal, and dock it to the berth. So if we look at our container vessel today, we have loaded some containers. It's not fully loaded, so it is just for this scenario. Typically it will be fully loaded. And we see here one very awkwardly placed container. This is the container that we're going to be looking at today. We're going to follow this whole container through the planning, through the yard, out of the terminal via the road as well. So normally there would not be a single container just at the top. I'm just mentioning it. Okay, so the vessel is passing the terminal, the passenger terminal on the right. I'm going to speed it up a little bit more. So we go to 60 times. And we can see here on the left already the container terminal. We can see the booms are up on the cranes, so that's all good. So the vessel can be docked. We'll talk about that on the terminal side in a bit more detail. So typically for the Port of Durban, bringing in a vessel to the container terminal as we're doing now would be 1.5 to 1 hour and 45 minutes. So we're really speeding it up at the moment. And there we go. So now the next step is to line fast. We want the vessel to be lined, connected to the quayside, so it doesn't run away at night or when there's a storm or something. That's done, and then we'll send the tugboats back to Marine Services. And there they go on their way. And now the vessel is docked. It's over to the terminal services to service the vessel. But before we go there, so what we can see on this view as well is we can see the time that each action took to complete. And it's very informative for the role players, but also for the instructor. And they can see where time was left out, what was idle. Was it the tugboats that were waiting, or were the tugboats not there when the vessel got to the point for line up? And all those kind of things give a good view of what can be improved in the processes on the Marine Services. Then as well in the Marine Services, they have a continuous role when there is a delay in a vessel, for instance, and it can't come in at a certain time. So for instance, here between 2 and 4, it might want to come in between 4 and 6, but now you can only service 2 vessels. So that is also the role of the Marine Services to make sure, and the Vessel Traffic Services to make sure that the vessels are serviced. And some ports have priority as well. For instance, I think Durban has container priority, so they have to service 2 vessels per 2-hour slot. And there's a lot of rules that need to be taken into account for the VTS services. And there's also the weather effects. Maybe there's too much wind for the pilot to go via the helicopter, so they need to plan it to use a pilot vessel. And also that takes longer, so you need to take that into account into your planning as well. Or maybe there are not as many pilots as you expected. And there's a lot of things and contingencies to take into account on the Marine Services as well.
I think all of these that we've just watched, which was actual detailed view, culminates to the point of the terminals. And it brings us to the point where vessels are being prepared and the tugs pilot was dropped in, the tugs brought the vessel in. And in the meantime, while this was happening, and the simulation gave us an extremely good view of this, the terminals are already preparing the berths, preparing the stacks. This is sometimes done ahead of time in advance. And when they do this, it's just like what we've seen now in the simulation, it ensures that the process is streamlined and there is no delay incurred when that vessel comes in. I'll be speaking about a little bit delays that could occur and the different roles. We want to move over into terminals for now. And all that has happened has brought us to this point for the vessel to work. So how does that vessel actually discharge its contents or the containers that might be on it in a multi-purpose terminal? It could be break bulk, or in a liquid terminal, liquid bulk, and so forth. In this case, we're talking containers. So how does this work? So there are different role players within terminals that are involved. And these role players play a very important role because in speaking to each other, they ensure that the process is not delayed. If you look at a container terminal, and some of you guys maybe are from container terminals, you might have questions as we speak, and as we say in the container terminals, there is always a day that something goes wrong and there is issues, there is problems, and what contingency plans we have in place. And that's how the simulation comes in with value, because what it does is we can put these scenarios within the actual simulation and see how it plays out prior to it actually being our plan B or our plan C and so forth. In doing so, we can eliminate these bottlenecks and these delays that can occur. The role plays I'm speaking about are your planning roles, your vessel planning, your yard planning, your rail planning, and also the equipment controller, the execution side of the planning process. To that, we will add a compliance officer as well, and then there's a documentation center that does a lot of the background information, the ensuring that the documents are in place for these containers to actually come off or go on to the actual vessel itself. So I want to just touch on here the compliance officer, and he or she also rounds up the process quite nicely towards the end. We'll see that just now. But the compliance officer, you will see he or she services that they conduct on a daily basis, sometimes hourly. They're adjusting the berth plan itself. Now, when we spoke about the berth plan originally, we spoke about it from the marine side. Now, at the terminal level as well, especially on your ports that are bigger and accommodate more vessels, and the traffic flowing in and out needs to be controlled, you find there's a terminal berth planner as well. The role of the terminal berth planner, I'll be speaking in a little while, but you'll find that they liaise with the compliance officer and they speak to them if there are delays, if there's processes that are not followed correctly and so forth. So the compliance officer will create service requests, for example, an estimated time of departure of that vessel, and they will send it to VTS or Marine Services and speak to them and tell them at plus minus 1800, we're expecting this vessel to complete and we need a pilot to have this vessel taken out. And just like we've seen in the simulation now, the Marine Services kick in and try to action it accordingly, but the compliance officer still interacts with Marine Services, with the vessel agent, with operations in the terminal to ensure that this is carried out accordingly. And if there is a delay for some reason, it's adjusted and the relevant parties are made known. And at the end of the day, we don't want a pilot to come to the vessel and find that operations are still ongoing, and that can create delays. Remember, you still get billed for that event, for the pilot coming out to the actual vessel. So we want to avoid that. And remember, these requests, like Voto was saying a little earlier, 2 hours in advance is given in certain ports to ensure that the requests are carried out. And certain terminals have contract vessels. And with these contract vessels, they have to be serviced as priority. And in doing so, we ensure that no delays occur with regard to this as well. They're also updating your various service providers, your vessel agents, and the sometimes even operations themselves. They also check for the completion. They ensure that stevedores are on board in time, and stevedores do the lashing or unlashing of that vessel, tying down of the containers to ensure that at high seas, when that vessel is at high seas, may incur a storm or so, and your containers are not falling off that vessel, so they lash correctly and so forth, and custom agents and so on. Sometimes bunkering is involved and ship chandling and so forth. So I want to move to the actual vessel agent themselves, what they do and how they do. So giving you an overview of the vessel agent, the vessel planner, it's important to understand the vessel planner's role is to ensure the cargo is planned sequentially to be taken off that vessel, or in the export case, put onto that vessel in a manner that it does not create delays. Also, we want safe working practices, and we're considering a lot of factors on the background to ensure that this plan is correct, is according to what's required. Sometimes we are working 2 ship-to-shore cranes, other times might be 4 in certain ports, depending on the size of that vessel. So the vessel planner will plan these containers accordingly. Most of your cranes you find are taking single moves off or putting onto that vessel. In certain ports, you're having your superposed Panamax cranes, and they sometimes handling quad lifting or tandem lifting. And you will find it needs to be planned in that manner. Sometimes you're looking at certain vessels take an enormous amount of empties to specific ports that require them, or maybe it's coming to the port. Just yesterday, a vessel came in with 700 reefer containers to the port of Durban. And in doing so, we're preparing for the citrus season that's coming up. So these kind of things need to be considered in advance. And the vessel planner is looking at these factors to ensure that it's done timeously. And when the plan is in place, we need to inform the relevant parties as well. And Bote is going to take us through now on the vessel planning side and give us some section views of the vessels and so forth and how it actually interacts with the vessel planning.
Okay, thank you, Brian. So if we look at, I've opened here in what we call Sparks, which is not a real Navis Sparks. It's used in the port of Durban, but it's an emulation of it. So it has the same features, not all the same detail, but it looks and feels the same. So it's a good training tool for them as well, for the role play, in this case, the vessel planner. So I've opened the Serangoon, the vessel that we just brought in and saw docking at the quay. And currently there's no containers because there's nothing planned. I'm on the plan view at the bottom left here. But if I go to current, we can see the actual containers that are currently on the vessel that is coming in. So typically this is sent via a BAPI file or an EDI from the previous port where this vessel was loaded. And it will also be sent again from this port once the vessel has been serviced and with leaving. So this is already sent to them long before the vessel comes in, typically 21 days, or it could be less as well, depending on the duration of the journey. And the vessel planner typically does this as well that many days ahead of time, depending on what information is available and what still needs to be done. So it's not something that the vessel planner does when the vessel is has already arrived at the terminal. It's done long before, because you don't want to delay and waiting on the planner once the vessel is there. You want to start offloading immediately. So if we have a closer look here at the cross section, and if you remember what I showed previously when the vessel was coming in the 3D, we saw there were a lot of containers at the front, and we also saw the one odd container at the top. So it's easy to see where that is. It's in bay 30. So the numbers at the top are the bay. They start at 1 at the front of the vessel, and they go all the way to 74 in this case for this vessel at the rear of the vessel. And we can see as well the colors. I can change the colors as well. In this case, they are color coded by port of destination, and the dark red ones are destined for Durban. So we need to take these containers off the vessel. The other color still have to go to another port, but we'll touch on that later. So I can click on a cross section as well, or on the bay, and I can get a cross section of that bay. So now it's obvious that one container was sticking out, and we can see that all the Durban containers are on top, which is good for the vessel planner, so he doesn't need to get all the containers first off that were on top of one for Durban and restow them, so put them somewhere else, or maybe put them somewhere in the stack and later put them back onto the vessel. But in this case, it's not necessary. The crane can start from the top and take all the Durban containers, the dark red ones in this case. So if we zoom in a little bit more, make this window a bit bigger, and we can zoom in at the top, and we see that one container that was at the top has a red 3. That means it is an IMDG of category 3. And the planner needs to know that because maybe it's a special handling, it could be needing to go to a special stack, or there could be other requirements as well. And for more information, the planner can click on it as well and pop up more information, what is in the container, where does it come from, who's responsible for it, and all this information is loaded by the pre-advised, which we just mentioned quickly in the commercial. So that's why it's important that a forwarding agent supplies all the data, what is in the container, so the planners can take it into account. Other important information is the type of container. So these are GO's general purpose. Our container is a T, which means a tanker, and also the weight. So this small number here is the weight of each container, which is also important to know for the planner. When you stack containers, there's also a limit, weight limit on the stack. You can see at the top here, these numbers are actually the total stacked weight. So that's also something to take into account when planning a vessel, or planning the yard as well, all over planning. So it's the job of the vessel planner to determine where these containers that are destined for Durban need to go. So I'm going to plan our special container because it needs to go to a different stack. So to do so, we open the yard view, which gives an overview of all the stacks that are currently in the yard. So this once again can be customized to your port. We'll go into more detail in the yard planner on this view, but it's important to know that the import stack is further away from the key, so we can see that is here, and we can actually, I've already planned all these containers to stack EE2, but now we want our container into the special IMDG stack, which is further away and closer to the road, so it can leave the port quicker. So to do so, in this case, I'm going to do it manually. I'm going to select the container, and I'm going to open up this view of the stack with the IMDGs. I can see there's currently already containers, so I need to plan around those. I'm just going to put it on the other side. There we go. So it will be in row 16 on the far end of it. So we can see that later it will be planned exactly there. So typically, a program like Sparks takes a lot of algorithms into account when you're planning. So typically the planner can just select the boxes and say, all go to that stack, and it will sort them by destination, by weight, and do all those things for you. But what we typically like to do in the simulation for the role players, to get a better understanding of how the planning works, what needs to be taken into account, we let them plan each box manually. So it's a similar process. They select each box and plan it on the yard to understand fully why it goes there, what is next to it, what is on top of it. So it's a manual process that the planner needs to do in our simulation. Then the next step for the vessel planner is to plan the sequences, as Brian mentioned, for the crane. So it's important that the crane takes off the containers in the right order. Obviously, you can't take a container from the bottom first, that makes sense, but you also need to take the balance of the vessel into account. You can't take everything from one side, say for instance, first port side, and then move to the starboard side. So that doesn't work. Also from the front and the back, you need to be careful when you're working with multiple cranes. So you can't have two cranes working at the front and then moving to the back. You want one at the front and one at the back. So it's the job of the vessel planner to sequence what we call sequence these containers coming off, and that's done by the point of work, which we'll touch on in more detail a little bit later. But currently we can see there are a couple of cranes on the quay side. If you remember from the 3D when the vessel was docking, there were a couple of cranes. And for our simulation today, we will be using CR5 to 7 and CR5 to 8. So we can see the numbers here, what bay it is servicing. So currently everything is already serviced, but now we want to add that one container that we did because we need to update it. So I'm going to select all the containers here and assign them to this crane again. Okay, so now we can see this second crane, 5 to 8, will service 4 bays, bay 30, 34, 38, and 41. And I can click in for more detail as well to see the actual sequence of each container coming off. And we can see at the top, that's our container. We can easily identify it. It's an IMDG. So once again, it's very visible what type of container it is, because sometimes it could be there could be certain requirements, maybe the crane, it could be out of gauge, different spreader might be needed. So it's important when the equipment controller executes the work queue that he knows as well what type of container it is. And we can see here all the detail, the information, where it is going, what type of container it is, the kind of move that's all being discharged in this case. So that is the vessel planner's role. So once he's done, the queues can be executed by the equipment controller, which we'll be touching on later. And it's typically the other role of the vessel planner is also to plan the box that the containers that are leaving, the export containers, and they need to be planned the other way around. So they are planned from the yard onto the vessel. So it's a very similar process. You pick up the containers and you determine where they go onto the vessel. So typical things to take into account then are what is the next port, and because you want containers for the next port on top, you don't want them at the bottom, so the next port needs to shuffle everything around. There might be restows as well. Maybe something is changed, it needs to go now to another port. So there's continuous changes as well in the whole chain that are happening, and everybody needs to be informed of that as well. Okay,
so I think that's a very good overview of how the vessel planner interacts, and also keeping in mind there are other role players while the vessel planner is actually planning these containers on or off the vessel. There are other role players that are already engaging with the vessel planner to make arrangements for containers either coming in, or the yard planner making space in the yard for the containers that are coming off the vessel and so forth. I want to touch on the yard planner at this stage. And the yard planner's role as well is key and important. At different ports, you get different types of yard planners. In some ports, especially with high volumes in traveling through the ports, you find that they have what's known as a forward planner. And the forward planner, his or her job would be to look at historical trends with that specific line and what volumes they handle and how they're handling these volumes. Like I spoke about reefers, seasonal reefers. You need to ensure that you're creating space within your terminal for these reefers. You have enough slots, you have enough cabling for them, you have enough staff for them as well. So these are key and important factors that the yard planner is considering when they're planning a specific vessel at a berth. Now remember, that yard planner might be considering 8 different vessels in a single port simultaneously, and they have to consider all of these factors filtering down to the IMDGs, the reefers, and the overheight containers and so forth. So in the yard, there are segregated areas for different types of cargo. For example, overheight containers does not go into a GP stack, a general purpose stack. And if you do put them into a general purpose stack, it might be that it's an open top, but not really a overheight container. And often enough as well, you'll find nothing is stacked on it because of the integrity of the container itself is not the same. The structure of the container is not the same as a normal GP container. The yard planner is also keeping in mind the various containers that are coming into the yard via road, via rail, and other vessels that are working simultaneously as well. And they ensuring that certain criteria is met. For example, which vessel your containers are for, like in export cases. Which ports of discharge they're going to, what types of weights are considered. Your certain lines have 5 different weight categories, others work with just 3. And this is important, especially for underdeck stowage. Your 8'6", 9'6" containers, this is your height of your containers, your length of your containers. All of these factors, the yard planner is putting together to ensure that when the planner is planning those containers from the yard or to the yard, that the allocations for that vessel's containers that are created in the yard work in a manner that it does not create delays again. And we're speaking about volumes here. And in volumes, you're looking at, if you are creating 300 slots for containers coming out from that vessel could be discharging 3,000 containers. So the yard planner is continuously changing the plan of the yard to ensure that we are accommodating the working of this vessel as well. And often enough, you find within the yard, there are housekeeping moves that need to be created. For example, if a container vessel has discharged their containers, they've loaded and they've left the port, Sometimes in the export stack, there are still some containers that are lying around and needs to be moved around to accommodate for the next vessel that's coming into port. So the yard planners create housekeeping moves to ensure this happens, and the stack, export stack that's created for the new vessel is clean, and they're able to create allocations for them as well. Now, Wouter is going to run through a little bit of the yard planners' roles and give us a good view on the stack.
Yeah, I think you explained it very well. I just want to show a little bit more detail of what I touched on the yard view. So we can see here this orange and yellow blocks. These are the export stacks. They're allocated for exports only because they're close to the vessel. And then the ones behind it are the import stacks. So the yard planner can say, okay, this stack is for this vessel here, or this even part of the stack. It doesn't have to be the whole stack per se. It can be parts of the stack. Also, depending, maybe the vessel is coming in next week, so you want a small portion of it. Maybe that's coming from another vessel that's being transshipped and needs to be stored for a week or more. That can be at the back, and as Brian explained, housekeeping can do that. So the yard planner typically uses a view like this and drags containers as well. So if we look at the actual containers that are currently there, he can create work queues very similar to what I've shown for the vessel agent, and then they will be executed by the equipment controller. Once again, the colors here are for the different destinations, so we can see the import are all for Durban, the dark red ones, and here there's a lot of different ports of destination that the planner needs to take into account. So typically they're grouped as well together, so they can be loaded onto the thing together, onto the vessel together. So that's the role of the yard planner. We can see on the left here as well, there's a reefer stack where all the reefers are stored. So a reefer is a container that is refrigerated, so it's important that it has electricity, otherwise the low temperature might not be maintained. So typically during transport there is a generator, but on a vessel it has electricity, and on the port as well. So it's important to know that, as Brian said, if that's because of the seasonality, it could be needed to have 700 reefers coming in, and they all need to be cooled and all that. So that needs to be taken into account by the yard planner as well, to make sure that that capacity is available. Similar to the yard planner, we have the rail planner. It's similar to the yard planner. I don't know, Brian, you want to?
Okay, so would also looking in the rail planning, I don't know if you guys might remember, about 2 years back, there was a massive explosion in Beirut with containers that were kept in the yard only. And these containers were actually explosive. And certain documentation needs to be put in place, like we spoke about earlier, in ensuring that these containers are segregated accordingly. Leave alone segregation in certain ports, like in our simulation process, IMCO 1.1s, these are all explosive. All the IMCO 1 categories, the IMCO 5.1s, the IMCO 4.1s, safety matches and so forth, are actually segregated in a manner that they do not even, or they try not to put them into the general purpose stack or on the ground at all. So if these containers do come in, they sit on rail, in the rail siding, until it's required by the vessel. And it's not called in days in advance. It's called in, I remember I said time sensitive. It's called in hours before that vessel actually requires them. And the rail planner is interacting with the yard planner and the vessel planner to try to coordinate this in a manner that these containers are timelessly available for that loading as well. And when containers come in that fashion, you will find that because they are explosives or they are highly flammable, there's a fireman on standby just in case of emergency and so forth, until that vessel, he will or she will escort that container all the way to the vessel until it's loaded as well. So the rail planner's role here is to liaise with various role players. Remember, some of our container terminals or our terminals are situated in such a manner that large volumes of your containers are either coming from over border countries or from inland destinations or hubs that supply you with hundreds or even thousands of containers for a single vessel. And the volumes sometimes are such that they need to be coordinated 3, 4, even 5 days in advance to get them into port timelessly for the vessel planner to have them planned and the yard planner accordingly to have them planned as well. So importantly, the rail planner is considering certain specifics. Now the rail planner is looking and trying to understand how these containers are coming in, when they're coming in and why they're coming in, and trying to make them available as well. So the view that we're looking at here, you're seeing a train that's at the rail siding. Now this train, or these rail cars as known to certain systems, you will find has certain specifics within them. Everything on the screen that you're looking at means something in the planning environment in Sparks, okay, or in any of your execution side of things. So they accommodate 20-foot containers, 2 of them. Other times, a single 20-foot. In certain countries, they accommodate 3 TEUs or 4 TEUs, depending on the infrastructure of that country. Well, in South Africa, like we showing you here, it's generally 1 high, so it's 2 TEUs per rail car. The rail planner is trying to ensure that they are discharging this train sequentially as per vessel, similar to that of the vessel planner. They work on very close similarities. They actually work parallel. And in doing so, certain containers go to certain vessel stacks, need to be planned accordingly. Now, when the vessel planner is looking for containers and it's sitting at a rail siding, this can create a bottleneck. Remember, I spoke about customizing. The simulation actually can customize the different processes that you use for your terminal. For example, you might have a straddle carry operation. Other terminals use a rubber tire gantry system. Others use a reach stacker or a forklift and so forth. There's different, no 2 terminals in the world operate exactly the same. They might use similar equipment and so forth. Others might have fully automated terminals. So these kind of scenarios can actually be inputted into the simulator, and you can see the various outcomes from these situations. Now, the rail planner is also considering, once he's planned either discharge or loading, or what's known to the system as inbound and outbound trains. They upload work queues, and we'll be touching on a little bit later how those work queues are addressed. Boja is just going to be running through the rail planner's view and giving us a little bit of what the simulation does and how it interacts and how the rail planner actually plans on the simulation.
So the rail planning is very similar to the vessel and the yard planning. So it's once again moving containers that are currently on, as I showed before, on the train. So we can see here a list of, there's only 1 train coming in at the moment, but there could be a list of more trains. We can see all the details of the cars or wagons, what is coming, what is its idea, but more importantly, it's also showing what is on there, what container is on there, where does that container need to go to, what is in that container. So for instance, the planner can see here, this container is a reefer container. So he needs to understand that that needs to go to the reefer yard. Otherwise the goods might be spoiled, the temperature might not be kept low enough. So it's similar as well. We got here on the work queues that I showed for the vessel planner, we got a rail crane as well. And it's the same. They select the container and sequence it under the rail crane. So with the sequencing of the crane, it's important to understand, do you want to start from the front, do you want to start from the back? Sometimes you might have 2 cranes, it depends on the operation and the configuration you have. So in the Port of Durban and in our simulation, we work with a rail mounted gantry crane, which we'll be showing later, and we can see here everything is already planned. We can see easily as well that there is a reefer in the work queue, so they need to take that into account when they execute that. And that execution is done by the equipment controller, which will be the next role we'll be covering.
Okay, importantly, when we're looking at the actual equipment controller, their role is key. As much as you can have a perfect plan put to paper and queues uploaded, it's important how the execution occurs. For example, there might be certain delays, a container might be missing or put into a wrong stack address that might be need to locate it. You need to locate it first prior to loading and so forth. So the equipment controller here bridges the gap and ensures that the actual queue that comes through to them is executed without creating any bottlenecks within the terminals. Remember, we saw a terminal view and we said specifically what it does. There's multiple rows within the terminal, and if you have a straddle operation, for example, like we will see very shortly and how it works, you can actually, in planning, you can work against the actual flow of the terminal by incorrectly planning containers. And this is actually important because the simulation will take us through processes. For example, many of your planners today in your ports are trained on the job. So they train by another planner that's already working. And in doing so, sometimes maybe 50% of that training actually carries through to that new planner. And they don't understand how to create contingency plans, why we shouldn't be doing certain or creating certain scenarios or planning in a specific manner. So what happens in the simulation, it shows you, even if you do make a mistake, it's not in real time. You are able to correct it and understand why you shouldn't be doing the certain role that you have done in a specific manner, because it creates these bottlenecks, it creates these delays. And remember what I said about delays as well. You can't have 30 staff sitting and waiting because of a bad plan that has come across from the planner. So the EC bridges this gap. And when he or she looks at certain specific plans, and maybe there is a problem in a specific stack where there are workmen, maybe they're repainting the lines, or maybe they have to do drilling, or maybe changing of lighting and so forth within the stacking areas. What they do is they try to work around, they try to resequence to some extent to avoid that delay. And this is done in conjunction with the vessel planner as well, or the rail planner as well. So when looking at the EC controller, they're executing queues according to what's been planned. And in the simulation, you will find, Boto will be explaining very shortly, there's different points of work that you have, which could be rail, it could be the road queue, it could be your gate, it could be a specific ship-to-shore crane that's working at the quayside, and so forth. You could even have your housekeeping work queues as well that can be executed. And you will also find to the points of work your equipment, or what's known as chaise in the industry, your container handling equipment, are in your pools and equipment. And from your pools and equipment, the specific equipment that you require can be pulled into a point of work and worked accordingly. So as you're seeing here on the simulation now, you will also see that how it directly impacts the EC and operations at the same time.
So the first step for the EC is to boom down the cranes, because we can see the booms are currently up. So I'm going to execute that. And that's once done from the work queues, we can see now the booms are going down. So that means the cranes can start servicing the vessel. And it will be done accordingly to the sequence that the vessel planner has created. So we can create the work, select the work queues here, and we can activate them, and we can see that the first crane will start moving. And similarly, we do it for the second crane, which is servicing our container that's on top. And if we zoom in, we can see them in a bit more detail. And the straddles at the background currently, they are bringing in containers that are being brought by road. We'll be touching on that a little bit later. So there's 6 straddle carriers servicing trucks coming in to drop off containers that are being exported out of the port. So as Brian mentioned, each crane has its own work pool. In this case, we have 4 straddles per crane. And each time that the crane will drop a container off at the quayside, a straddle carrier will come pick it up. So different processes are also possible. It's possible with a truck system where the container is directly dropped onto a truck and brought to the stack. And we can see as soon as the container is dropped. So in the simulator, the straddles are waiting there. In real life, obviously, they'll wait closer to the crane. It's just to wake them up. So the drivers were still sleeping. So we can see the straddles now moving towards the container. In real life as well, the straddle driver actually sees on his terminal, once he picks this box up, exactly in the stack where it needs to go to. So it will tell him EE, row 7, bay 5 or something. And so that he knows exactly where to go to. He presses the button and then the system knows, okay, from now on, that container is at that location. So that's how the system keeps up to date with what's happening on the ground. So it's not just the planning, it's also the execution and the current situation of the port that can be viewed. If I zoom out a little bit, we can see that one straddle already dropped a box there into our import stack, which is behind the export stacks. And we can see that our container is taking a different route. That one is going to the stack for the IMDGs, as you saw the vessel planner doing, which is all the way at the other side of the port. So that one still has quite a while to go. But in the background, we can see that the other containers are being offloaded by the other straddles. So it's a continuous process that's happening. So we can see our container moving along the other export stacks, taking a turn. So we can see, as I said, there were already IMDG containers at the stack, so we can see them here. So once again, the role players can see in 3D how their plans actually come to life, which is a good benefit because in real life, the planners, in the case of Durban and I think in other ports as well, they can't even see the containers. They can't see. They sit in an office building somewhere. They don't have the touch and feel of what's actually happening in the port and how is their plan being executed and how does it impact me and others. How if you change something in your planning. Okay, so we can see the containers being dropped, and the straddle will now go back to the crane to get another box. So while this process is happening, there's a lot of other processes happening at the same time. So if we look at, for instance, what's happening at the rail, there's the rail. We can see that there is a train that has arrived with all the containers. We can see there's a wide reefer at the front, but nothing is happening. And that is the role, once again, of the rail EC controller. So there's different equipment controllers in the port. So now the rail equipment controller needs to make sure that, yes, the train has arrived, the crane is ready, there are trucks or mafis in this case to pick the containers up. So once that's all satisfied, similarly to how we activated the crane work queues for the vessel, we can activate the rail work queue. And we can see that the crane is moving. So as I mentioned, it's important to sequence your actions correctly. So this one is sequenced from the front of the train to the rear of the train. So typically you would already position your crane before the train arrives. And similarly to the vessel, we saw the cranes move first to the front of the vessel. Typically you want them already in the right spot to start offloading quicker. I'm going to speed it up a little bit more.
I think in the background, you'll also find that your terminal trucks are already being prepared to get to the railhead for this. That's what EC does when he starts executing his queues.
Yeah, so we can see here the containers being loaded on, it's a Mafia, it's a brand of truck. It's a very simple truck that's just internal for the port. It's made to carry a container. And once again, it depends on the availability of the number of Mafis and straddle carriers, how your operation is done. So we can see the trucks or the Mafis have to go all the way around the train and then come back here to what's called the interchange zone. So we can see some other trucks as well. Those are the trucks coming from private transport companies bringing in containers into the port for exporting. And they wait at the interchange zone until a straddle carrier will come pick up the container and drop it off in the yard. So the trucks are not allowed to go into the yard. You don't want to interfere with them. It will be dangerous to have them driving there. So we have a straddle at the interchange zone to pick them up and then drop them off at the right location. And then as the trucks come in from outside the port, there's a gate system as well. They have certain allocated times that they're allowed to come in. So they're filtered as well. So if the outside of those times the stack is not open, maybe the vessel's already left, they're late, they're not allowed into the port, just to prevent congestion in the port of trucks, which can be a big problem as well if that's not monitored. And then during the offloading, the planners can monitor everything in real time as well. They can either watch it in 3D, but they can also see what is happening on the points of work, how far are they. So we can see crane 5 to 7, we can see a green arrow here. So it's finished offloading the first 10 containers from the vessel, and then it moves on automatically to the next one because I activated all the queues. So it's EC controller as well to keep an eye on what's happening. Maybe there's a crane breakdown, there's delays. There could be anything happening, and it's important to keep watching what's happening. And if there is something going wrong, there's a compliance officer, which role it is to make sure that everybody's aware of delays or what's happening in the port.
So in the execution of what you're seeing happening here on the simulation itself, you will see the stacking areas. It looks very neat and tidy here in the simulation, and we've done that on purpose just to show how sequencing is done and how containers come in and leave. In a real-time environment, if you're from the port, you will find that there are sometimes containers scattered in a single stack itself. So housekeeping plays a very important, vital role here because the EC controller is trying, as much as a gang is discharging, or maybe multiple gangs are discharging this specific vessel, a rail gang is also working on the other side, and that might have a specific EC controller, as Bota has just said. But also to that, there's a housekeeping gang that's working in areas within the terminal that's not affecting the operational process. And in doing so, they're cleaning out stacks or ensuring that containers are stacked according to what they should be in the terminal itself, ensuring that your rules are adhered to, like your segregation and your IMDG containers, your overheight containers, and so forth. And in the housekeeping, I think it plays a very important role with the EC controller on how this is done, and it should be done way in advance to ensure that stacks are made easily accessible for vessels, for rail that's working, for road, and so forth. Like Bota was saying, to round it up very nicely, the compliance officer is also keeping an eye on these various actions that are happening in real time, and in doing so, they ensure if there's a delay that they adhere to certain specific rules, especially the time-sensitive rules, and speak to marine services and advise them that this delay will actually, we're pushing the sailing time of this vessel back by another hour, and they will action it accordingly. So I think that brings a good conclusion to the actual simulation itself.
Yes, and that's why the change simulator also plays an important role, because it gives an experience to all the role players to interact with one another, but also to see what is happening in the port and how their actions influence other people. Then finally, before we finish this demo, I just want to quickly mention the contingencies and the emergencies that we have in our simulator, because obviously what you can do in a simulator is sometimes you can't do it in real life, or you can't train it in real life. So in the simulator we have two emergencies for the vessels. We can either have a fire on a vessel that can be triggered on any position. So it could either block a terminal, it could be even blocking a waterway, and how do they manage that and how do they work around that? Who's involved? Is it marine? Is it terminal? And then we also have a vessel running aground, which is very similar as well, and who needs to be notified. It could even be other role players as well, like your municipality or other provincial or government organizations. And then finally, on the resources, we can have breakdowns on the cranes and straddles as well. Straddle breakdown is just your capacity going down, but if a crane breaks down, it could be in the way of other cranes as well. So it might need, they might need to shift the vessel or warp it or move it to another berth. Okay, so that sums up our simulation demonstration. Just as a reminder, after the final presentation given by Teves, we will have a Q&A. So if there's any further questions, please ask them now, and we will try our best to answer them after the presentation by Teves.
Okay, so I have the pleasure of concluding this, and I think what's important here is that my colleagues Brian and Wouter have shown you exactly the detail and the scope of what simulation can do in your port environment. And what's critical to understand is that, you know, as buyers and sellers are putting pressure on your supply chain to fast track the movement of their goods, it's very, very, very important for the ports and the port authorities to try and keep up with this game. Otherwise, they're losing business. You know, people are now using ports nearby, and they're using rail and road to move their cargo between from the buyer to the seller. So I'd like to conclude by drawing a very important question. What is the scope of simulation towards port 4 and port 5? And I think what we've seen is your simulation for technology that we just demonstrated to you in our LSE sim, you know, can really help you towards expanding your port by using the digital twinning technique. Right? We know, and we've seen it, and we've actually implemented it, where simulation for solves your integration and interoperability challenges, especially when you're mixing new and old. To try and do that by buying hardware and using hardware in the loop, it becomes very challenging and very expensive exercise. And this is not only applicable for intermodal transport, it's also applicable on the terminal side, quayside, your marine services, in the water side. By simulating your equipment and all your hardware, you can actually fast track your port evolution. And that's why we're here today, is to show you the benefit of this simulation in achieving this. So what we're saying is, use simulation to develop your talent, fast track skills development. You can fast track training from months to days. When you think about it, a typical port is a few square kilometers. For an employee to be exposed to every part of every operation within the port environment, to understand how this whole ecosystem works, sometimes takes months. But in a simulated environment, you can literally reduce that to days. Another important thing is, due to safety measures and also the criticality of the operations and the operations in terms of the timing and stuff, it's hard to take people through the port and show them what's going on. So in a simulated world, you get the opportunity to be immersed and interact with the different elements of the port. I think Brian and Wouter touched quite a lot on scenario planning and the value of scenario planning. Having the right sizing your equipment, having the right number of equipment, right, allows you to do a lot. So your automated planning allows you for asset swapping, rerouting equipment from terminal to berths, and berths from different terminals to different terminals, and then also amongst berths, right? And then adjusting your routing within the terminal, using road and rail to make it much more efficient and more effective. And I think everybody sees the benefit from what you just saw now is your performance monitoring. Because this is a time-based environment and everything is determined in sequence of time, and your weather and your failures and your bottlenecks in your port environment can be modeled to show you what your real-time performance and how you can control this environment using simulation, and then go back and implement these studies in your port environment to verify that your strategies around planning and improving your operations is actually paying off. You can use it for benchmark studies against other ports, because sometimes ports are interconnected, as I said at the beginning. One port feeds the next port, and the current port will feed the following port. And if you're not working in harmony and synchronized, you're going to create unnecessary delays. And I think a very important thing in the ports environment, many countries' GDP is controlled by the movement of cargo through the port. And your throughput optimization is of paramount importance to ensure that your country economics is actually improving by reducing your logistics time and your logistics costs. Right? So your simulation studies for automation, process reengineering, and performance studies would greatly enhance your ability to achieving the right-sized Port 4 or Port 5 technology. Right? So what we're trying to say to you guys is, you can migrate to Port 4 or 5 with our LSC sim, but what are the major benefits of the LSC sim? The first and the most important thing that we're seeing is your talent development. The maritime port environment being so large, it's difficult to grow employees and develop them. They need to understand their customers, they need to understand their suppliers, internal and external. And in this environment, using virtual training on our cloud-based platform, we could actually assist you to develop your employees and your consultants and contractors that are working in the port environment at a very low-cost implementation, a very affordable implementation. We also have the ability, and we have done this, where we've done a full-on local installation on client hardware, right? The other beauty of this whole environment is we can customize complete hardware and software installations, and we can customize your local ports and terminals to exactly how it operates in your real world. We can help you develop new standard operating procedures to improve your efficiency and reduce your throughput, increase your throughput through your port. And then, as my colleague Wouter was talking about, all ports have disasters. And it's important to plan for them because these disasters can cost you in terms of basically crippling an entire terminal or crippling your waterway so that you can't move your cargo. And I think recently we saw what happened in the Suez Canal and the knock-on effect it had on the entire globe, whereby people were waiting for cargo, food was being delayed, all sorts of things. The backlog of vessels at the entrance of that canal was just amazing. And as you know, we are a group of engineers, some of us aeronautical, some of us mechanical, and we have the ability to offer you detailed maritime consultancy services by implementing digital twinning to expand your port. And that's extremely important service that we could offer you, especially if you're in a port 2 or 3 environment and you're looking at migrating upwards, right? Your process optimization by continuous improvement through real-time stochastic modeling. So not just looking at static modeling and dynamic modeling where everything works well. We throw in a few failures that happen randomly through Monte Carlo simulations. We can also look at your vessel traffic service development because moving vessels in and out of the port as quickly as possible is key, especially in high winds, bad weather conditions, and narrow channels, low berth, low draft, and how do you move your port around? So the other big thing for me is, what we're talking about is your port 5 environment, where we're looking at your port-to-port integration and planning. To get ports to talk to one another seamlessly, why not simulate it? Because rather than spending on the infrastructure of mapping hardware and communication hardware and sensing systems and real-time location systems and stuff, do it virtually. See what the benefit is. Is it really adding value before you invest in that infrastructure? And I think on that note, I'd like to hand over to my colleague who would now take over the Q&A session. And I believe we have some questions. So yeah, we look forward to it. And guys, we're just an email away, given the complexities of COVID, and also a phone call away. And most of the time now we're all using WhatsApp and all these funny online chat programs, and we'll answer whatever questions you have online and via chat base. But sometimes it'll help calling up a meeting where we could actually present to you detailed solution to solve your problems. We just did that today with the Jamaican port. And just a one-on-one with them actually helped to improve the relationship, and it also got them thinking about what are their options. So on that note, I'll hand over to my colleague Mariana, who will then deal with the Q&A, will end the session, as well as tackle some of the Q&A.
Very well, thank you. So we have our first question saying, how long does it take to model a port with 5 terminals and modern cargo handling equipment?
Okay, I can answer that one. So there's a few things to take into account once we start to develop and look at a port. So for the layouts of stacks and terminals and equipment like cranes, straddle carriers, that's flexible and configurable. If we look at the 3D, it might be more involved. So that depends. Maybe there could be data available. What is the required detail on those kinds of things in the 3D? So there's two parts of it. So on the setting up the terminals, we're looking around, I think, for 5 terminals, it could be 3 to 4 months, I would estimate. For the 3D, it could be a little bit longer, but it's more of it's a detailed question that we like to answer in a discussion with you. So we'll contact you to set up a meeting and discuss it from there. But those are rough estimates. I see there's another question. Can you work multiple birth and terminals at the same time? Yes, you can. So typically, what we do during training, we focus on a single terminal because everybody understands what's happening. But marine services, for instance, they'll be continuously bringing in vessels to other berths like the passenger terminal, the RoRo, liquid bulk, multi-purpose for a container simulation. But during the training, we service like one terminal at a time because everybody needs to understand and needs to be involved. Otherwise, there's too many role players in the simulation that need to get involved, and there's too much happening at the same time where people don't fully understand what's happening. So it is possible, yes, we can offload vessels at different terminals at the same time. We can berth vessels, we can sail vessels at the same time. But we advise during training you focus on a single terminal, whether it's multi-purpose, liquid bulk, or containers, as we've shown today. Then there's another question about the training programs that we offer and how long they are. So typically we offer the induction training, which is a week or 5-day training course, and that we offer either, as we mentioned, cloud-based, and we can either send a trainer like my colleague Brian over to do it locally, to do the training locally, or we can do it remotely as well, as we've been showing you today. Then it's more of a classroom environment where there is a direct interaction with us, the simulator operator, with the instructor as well. Then we have planning programs as well. For the planners, we have for the maritime, typically those are 2 to 3 days. We have a contingency program as well for the compliance officer, contingency management. Those typically take 2 to 3 days. So the induction is 5 days. It's a long course. It's a full-on 5-day course. The other ones tend to be a little bit shorter. Then there was another question on, is it possible to create an air freight logistic chain simulator? Yes, I touched on that briefly at the beginning. What we're looking at currently is a port simulator, but it's also configurable to create or add even. It can be intermodal, it can have air freight in it, it can have multiple rail stations inland from the port as well. So that's also a possibility that we can look into, and we can extend our simulator to incorporate that as well. Okay, I think I've answered all the questions. If there's any further questions, as Tibes mentioned, you can always email us or contact us for more information or have a discussion.
Very well. So thank you on behalf of the TMI Dynamatics team. As Tibes mentioned, we're just an email or a call away. And until the next time, see you.
Ciao.
Bye.